Okay, so what I'd like you to do is we are, looking. Today I'm going to give you an intro into anti-differentiation or reverse differentiation, if you like, and integration. But before that, of course, if you've differentiated, well, then most of the things should appear obvious. You can just go in reverse. However, in Chapter 7, we will be looking through quite a few techniques that you haven't seen yet. So, first of all of these can be anti-differentiated without a calculator. However, there's a few techniques that you wouldn't recognise. What I'm going to do is now, and if you're watching this video again, I'm going to get you to have a look at all of these 10, and I'm going to get you to write them down, and next to it, I'm going to get you to anti-differentiate by recognition. In other words, you should be able to recognise which of these you could virtually do straight off your formula sheet, or you might have to do some manipulation, all right, to get it to look like what's something that's on the formula sheet. Now, the hint is that 2 cannot be done. That doesn't mean that it can't be done, but it just can't be done by methods we've shown you so far. And there also might be a hint, you may have to do a division of polynomials. That could be one of the options. So I'm going to pause the video now. I'm going to get you to write those 10 out, and I'm going to get you to anti-differentiate by hand where possible. And I want you to recognise which one of these ones you simply can't do with what you know so far. So I'll pause it now. We're back in the room. Okay, so this one, I'd like to go through each of them. Now, first of all, you can do these by recognition, but when I anti-differentiate that, so the antiderivative, I'm not going to write it for all of these, but the antiderivative of 1 plus x squared, and don't forget when you're doing the antiderivatives, you're always doing it with respect to x. You will lose marks in an exam. If you do not do that with respect to x and you left that blank, you would lose a method mark somewhere along the way, I can guarantee you. All right, so always remember that we're anti-differentiating with respect to x in this case. So that is equal to, straight off the formula sheet, is it not the inverse tan of x? Is that right? Yes, okay. Easy peasy stuff. What about this one though? What do you think we can do with this one? What did, can someone put their hand up and tell me, what did they do with this one? Yeah. Substitution? Oh, no. Number 2. Yeah, all right, I'm going to get into that in a moment, but there's something that a really important thing that I wanted to mention. I'm going to refer you to the formula sheet. Now, I'm not going to write out all the formula sheet to get you to write it out. This stuff is simple enough, but there's something that is missing from the formula sheet, and I'd like you to make a note of it, and it certainly would be in your bound reference, and that is that the antiderivative of g dash of x over g of x is equal to, with respect to x, is equal to log to the base e, the absolute value of g of x. And that is a major omission from your formula sheet. And I'm telling you now that a lot of students don't recognise that if you see some form of the derivative on the numerator, or maybe you could manipulate a fraction to do that, then it's pretty fair to say that your formula sheet isn't going to help you with those ones because it's a big omission, all right? So make sure that you take note of that. Given that I've told you that, and that you maybe try a few of these questions, you should realise that when you get these questions, that with this one, that is the same as, if you like, that is the same as writing, let's write it out, and you might want to do that. And this is what I would do. I always write the derivative of the denominator on top. That's 2x. I'll leave the denominator as we were. And what do I have to do then, if I am anti-deriving my original? Well, what do I have to put out the front to make that 2? So I actually, well, what's the derivative of 1 plus x squared? It's 2x, but I had x, so I have to put out a half, don't I? Okay, yes. So now we've done that. This is straight. Really, this isn't off the formula sheet anymore, is it? Because it doesn't exist. But I can tell you that g dash of x in this case is equal to 2x, and I can say that g of x is equal to 1 plus x squared. That all checks out, which means that once you have almost recognised this is the thing that's missing from the formula sheet, then by recognition we can say that the antiderivative of that is equal to a half log to the base e, don't forget your absolute value, of 1 plus x squared. Now, why could I maybe just remove that absolute value in this case? Why do you think that? Like, yes? It's always positive. So you can remove it, but do not remove it straight away. If it can be negative, then you don't remove it. You leave it as the absolute value. And of course, what is the one thing I've been omitting in this? What else have we? Yeah. Now this is plus c. There's a plus c, but can someone tell me if I was integrating with terminals, where does the plus c go? Well, the plus c, when I integrate with terminals, let's say I'm saying 0 to 1, okay, of let's just say x squared, then dx, then remember that when we're integrating, we actually are integrating the x to the power of 3 over 3, and remember that we actually do have a plus c there, but I guess that plus c is taken, it's actually taken out or cancelled out. So it's like a plus c and a minus c. Okay, if you subtract a plus c and a minus c, it's subtracted. So we don't have the plus c's when it comes to having terminals. All right, so, but just remember all of these are technically plus c. All right, and if we have some initial conditions, we can find out what c are. But for this exercise, I'm going to just get through it a bit faster. What about this one? You guys should be able to do polynomial division. And the hint for these ones, this is polynomial division. I'm not even going to do it, but the first step is, because that's a basic methods technique, but you need to do polynomial division first. Where's another one when we have to do polynomial division? The next one as well. So these are both polynomial division. And what if the power, you can see there that if the power is equal or greater value, then that's generally a good hint that polynomial division has to occur. Okay? Another thing you can do is split two fractions up. If this was 2x cubed plus something over maybe x squared, you might have to split those fractions up, which is just a basic technique. All right, so far this one should be pretty easy. The antiderivative of that is equal to, is it sine or cos? It's the inverse sine of x, straight off your formula sheet. Well, this one then, we just have, therefore, it's just a constant out the front, so it's 4 inverse sine of x. What about this one here? What do we do with this one? First of all, recognising from the formula sheet. From the formula sheet, a is equal to what? A is equal to 1, but I guess in this case, a is equal to 2, yeah? Okay, so if a is equal to 2, but we've got a 1 on the top, so we have to take out our 4 out the front. So we want to get it to look like the formula sheet. So what we've got to have is we're going to have 2 squared minus x squared, okay? Which means that, and of course that's with respect to x. So if I was then to do that, I can say that that is 4 inverse sine of x over a on your formula sheet, which is x over 2. Did we get that? Good. All right, so I think we're pretty right with these. So really this sort of stuff is 7a and 7b. I'm going to be moving on to the substitutions probably in the second lesson. So, all right, so they're okay. What about this one here? What about this one here? Can that be done? That's a substitution which we're going to get to. And I might briefly introduce you into this, but I'm not going to make it another 20 minutes of video, but I will introduce you to that. What about this one? Take out the 4. Okay, so we'll do that. Let's do that. So the antiderivative of 4 outside of 1 minus 4x squared dx is equal to, well, let's take the 4 out the front. We've got 1 over, and let's in the square root, let's take out 4 as a common factor. And then we've got a quarter minus x squared. Good, dx, don't forget that. And now if we take out a factor of 4, that means it's going to be 2 on the numerator. 4 over 2 is going to be equal to 2. So we'll take a 2 out the front, which is now, that's looking a bit more like it, a quarter minus x squared. Okay, that's looking a little bit better, isn't it? So, dx. And of course, if we wanted to antiderive that off the formula sheet, you'll recognise that a is equal to a half. And that's just x squared, which is good. So therefore, the antiderivative of that should be 2 inverse sine of, yeah, x on a half. A is a half. Yes? So therefore, that's 2 inverse sine of 2x. Are we making sense so far? Is that all right?
Yes.
Is there anyone? No? It's all good? Okay. All right. Now this one over here, I just wanted to stop and make a bit of a point on that, because in Gen A, you've done something called partial fractions. Now, I'm going to go through it and show you. Now, I'm going to do it, and I'm going to give you a bit of an intro into partial fractions. Again, you've seen it so long. Yeah.
Sorry, what was the question exactly?
Yep.
Are you saying that's for
Partial
partial fractions?
fractions.
Can't you just use the inverse tan?
No, because inverse tan is plus.
Oh,
Yes, okay. Now, let's have a look. First of all, I'm going to consider this function. I'm going to say, well, let f of x is equal to 4 over 4 minus x squared, which is equal to 4 over 2 minus x, 2 plus x. Now, we know that we can't antidifferentiate that as it is. However, if I let that equal some constant a over 2 minus x plus some constant b over 2 plus x, suddenly we can then manipulate this into a form or something that we can understand. So, we know that if I want to get the common denominator, what do I have to do? Well, first of all, we know that I have to multiply this fraction here by 2 plus x. And I also have to multiply this b by 2 minus x. And of course, really over the other side, we've got 2 minus x, 2 plus x, but that's not really needed because they're going to cancel each other out on the other side. So, of course, these are going to cancel out, and we're really just looking at this fraction here. So, a, 2 plus x plus b, 2 minus x is what we're looking at. So what we need to do is we need to solve for a and b. So, in this case, it's pretty straightforward to let x equal negative 2, which means that on the left, we've got one equation which states that 4 is equal to, that's going to cancel that out. So we've got 4b is equal to 4, and therefore we know that b is equal to 1, and we're going to let x equal positive 2, which is going to give me 4a is equal to 4. So therefore a is equal to 1. So now if I consider that my fraction over here is now the equivalent of 1 over 2 minus x plus 1 over 2 plus x. So let me just pause this video for a second. I'll do some rubbing. Resume the video. So with this one, we said that 4 over 4 minus x squared. Now if you did this in an exam, that's perfectly fine. That is equal to, with respect to x, that is equal to 1 over 2 minus x plus 1 over 2 plus x. And that is with respect to x, like so. And what you can do is you can do partial fractions in your head. There are methods. I won't go through it today. Otherwise, but this is, you can actually do it in one step. If you can do it without doing any working out, if you write partial fractions in an exam setting, that is perfectly fine. They do not need to see all of the algebra and stuff to happen. But I'm going to tell you that if you think you're that good that you do it in your head, that's fine, but don't make the mistake. All right? I always do it on the side. Okay? Just in the little top corner, I do it my partial fractions because that means I'm less chance of making mistakes. Now, of course, on our formula sheet, which we discussed before, this is looking a bit more handy now because I've got g of x and I've got the derivative on the top. So you can see there that the derivative on the top is the derivative of 2 minus x is minus 1. So all I have to do is, if I anti-differentiate just that by recognition now, that is minus log e to the absolute value of 2 minus x and plus log e, this is an absolute value sign by the way, log e of 2 plus x. Okay, technically the plus c as well. Now, I then have to add them. What can I say? I use my log laws. Log e to the absolute value of 2 plus x over 2 minus x. Do you agree with that? And we're done. Yeah, technically there's the plus c there. Now, generally speaking, you don't just anti-differentiate. You anti-differentiate or you integrate with terminals, in which then you'd have to evaluate a value. Yes, do you have a question, Lloyd? Yeah. Yeah, so you say that again?
When it asks to find an antiderivative, you don't have to include the
That's
c.
right, you don't have to, yes, exactly right. So an antiderivative would be, you could say such that c is equal to 0 or something like that. So yes, you're right, but generally speaking, in the context of your exams, you just don't do straight out anti-differentiation, you tend to do integration. Okay, which the plus c is not included because it effectively cancels each other out. So, how are we feeling about those? Now, pretty much what I'm saying to you is that yeah, we're still going. What I'm saying to you is that this method here, this substitution method, I'm going to go through. And this one here, partial fractions, we're going to go through some more, but you should find them pretty straightforward once you get the hang of them. I will also say that going to your formula sheet, this has to be memorised. You have to be able to recognise by the end of this week all of those, okay, and also your division, when you use partial fractions and so on. Now, I would expect first thing next week that you'd be able to recognise straight away. Maybe not now. The next thing is, of course, this is on the formula sheet, or should be on the formula sheet, but it's not. And really what's missing, and what I'm going to go through with you this week and next class, perhaps, maybe just tomorrow, is we're going to go through, and this is what I'd like you to write down in your notes, is that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but there's also an 11, a 12, and a 13. And what are they? Well, we've identified one of them. We basically use a chain rule to differentiate a lot of things. We can use a chain rule in reverse by basically using a U substitution. So there's a method called using substitution, which we're going to go through soon. There's also a method called using trig identities. Ah, yeah, well, that's why we learnt the trig identities, because we do have to use them again. All right? And there's also a method which is using partial fractions. So, if you can recognise, and of course there's also, it's not really a method, but it's just remember as well that there's also polynomial division. I'm not looking. Division. How bad is that? Is that all right? Oh, that's terrible. It's pretty bad. It's pretty bad. Okay. At least that's polynomial. Okay. Okay. So these are the 14 things that you need to be able to recognise these by the end of this week. Okay. You need to be able to recognise this almost immediately, because otherwise you'll go, how do I do that? Well, it's usually generally that one there. And of course, you'll also have to be able to use that with that one as well. And we're going to go through these this week. Okay, how are we feeling about that? I think I might stop the video there and maybe create another one a bit later. So I'm going to stop that